Welcome everyone to Ready, Set, Roman training series. I'm very excited. This is our kickoff webinar. Roman is just under a year away from launch, and now is the time to really start preparing because Roman is a bit of a different mission compared to maybe traditional observations on Hubble or Webb, and we need to start thinking about this a little bit differently and starting to prepare now. And a lot of you, I'm just going through the list, are new to the Roman mission, and there's been a lot going on. I'm not going to fill you in on everything. Today, we're really focusing on the training series and specifically understanding what we're calling the core community surveys. And we're going to talk a little bit about what those surveys are and how to understand them a little bit in more detail. My name is Ori Fox. I am the Space Telescope Deputy Project Scientist. And I'm very exciting. We have the call for proposals coming out in the very near future. So things are really starting to ramp up. As I mentioned a few minutes ago, many of you still weren't online, but we are using Slido to ask questions. I haven't used it too much, but you should be able to open that up in the apps within WebEx here, and you can either ask questions or vote on other questions. And at the end, we will go through those questions in priority order. The presentation itself is about 25 minutes. And so we'll have plenty of time for questions at the end, followed by a little demo on one of the tools. Okay, let's get started. Here is an outline of what we're going to be talking about today. We're going to start off with an introduction to this training series and look at some of the other webinars that we have planned. And then we're going to focus a bit, not on the whole Roman project or the telescope, but really on the user support ecosystem and understanding what tools are available at your disposal to start preparing for understanding the Roman mission and how to use the data. And then we will specifically look at what we call the community-defined surveys. This is a bit of a new concept, and so I really want you to understand what this is all about and how you will be able to use the data from these surveys for your science. And then finally, we'll talk a little bit about the community and all the different ways that you can join and participate and prepare. Okay, so first things first, the Ready, Set, Roman training series. This is a hands-on training series designed to prepare the community for Roman. By the way, I've seen a couple messages pop up. If you have trouble hearing, sometimes you have to connect your audio depending on how you've connected. So just look for that audio connection button if you're unfamiliar with WebEx. This series is Roman's launching target date is in fall 2026. And the first call for proposals is coming out very soon, fall 2025. So now is really the time to get ready. And so this training series will help you build the knowledge and skills needed to make the most of Roman's core community surveys and also the general astrophysics surveys with specifically the wide field instrument. And we'll talk about those two different surveys in a few slides. Right now, we have 6 planned webinars. Today is the kickoff. We're going to be talking about simulations in 2 weeks, then the astronomer's proposal tool, then the Roman telescope proposal system and the proposal process, then the exposure time calculator, and finally the Roman research nexus. In many of my slides, you are going to have you're going to see a link. I will make these slides available after the webinar. I will post them online as well as a recording of this talk. And you'll be able to access all the links for the different tools and web pages that we are going to discuss. So first things first, the call for proposals it's expected this fall. Funding will be available for data analysis. Okay, that means not just new observations, but data analysis of existing observations that we're going to be talking about today from the core community and community-defined surveys. Funding will also be available for PI-led general astrophysics survey programs for new observations. It's really important to understand that all Roman data, no matter how it is taken, will be public with no proprietary period. And many of the surveys that we are going to talk about today are designed to maximize science across the board, depending on your science case, with no specific single science driver. And so now is the time to start preparing for that reason, because 75% of the mission is already defined, and you need to figure out how to start preparing and taking advantage of that data. So here are some of the tools that are at your disposal. This is what I call the user support ecosystem. Roman is a distributed project. We have several key partners that are all working together for you, the science community. We have the Project Science Office headed out of NASA Goddard. We have the Science Operations Center here at the Space Telescope Science Institute in Baltimore. And we also have the Science Support Center out at IPAC in California. And we all have our own responsibilities that all overlap and interact, and we are working together to get this mission launched. The tools that are at your disposal include things like documentation. We nickname that RDocs. We're going to be talking about all of these in a little bit more detail throughout the course of this webinar. We have a number of different proposal tools to help you get ready for your proposal. One of them is the Roman Telescope Proposal System. We want to highlight that. That will be used to submit your proposals. We have data simulation tools to help you start preparing now prior to launch. We have the archive mast where you will be able to access all the data. And the SOC is also developing the Nexus, which is a cloud-based platform, the Roman Research Nexus, which is a cloud-based platform that will allow you to work at the data on the cloud rather than downloading petabytes and petabytes of data. We, of course, have the pipeline, which we call Roman Cal. That's our calibration pipeline. We have a number of community-defined surveys that you will be able to access. And of course, we have the Roman community, which will be able to work, you'll be able to work with as you prepare, especially if you're coming from an institute where you don't necessarily have a lot of collaborators. The Roman community is building up collaborations and science teams now. As I mentioned already, but it's worth restating, all data will be public. That means no proprietary period. You can access it on MAST or the Nexus. And we will also have data releases at set intervals, which will include things like updated reference files, calibrated data, image coads, catalogs, difference images, and community contributed products. All right, so let's get into some of the details here. I mentioned RDocs already. This is the user-focused online documentation hub for Roman. As I mentioned, all these links will be available when I post the presentation. RDocs has essential information for the science community, including user guides for the Wide Field Instrument, WFI, the Astronomer Proposal Tool, and simulation tools. A large number of articles are available right now. This site is live, and many more are in the works. The Roman Telescope Proposal System. This is something you may not have heard of before. When the General Investigator Call for Proposals comes out, we'll be inviting the science community to submit proposals on a range of different categories, including a general astrophysics survey, guest investigator, theory, archival, and new observation programs. And all that will go through the RTPS. Here is a screenshot. I believe it is currently live. You can't actually submit a proposal yet, of course. But when that call becomes live, this will all open up. And we will have a detailed webinar on the RTPS December 9th, which is in about a month, although that date is still tentative. So keep an eye on changes. There are several other proposal tools. There's the APT and the ETC. We're going to have future webinars on those as well. I'll talk a little bit about those in future slides. But altogether, these are going to be your primary tools for putting together a proposal. We also have data simulation tools, several of them. We have STIPS, which is used for creating simulated astronomical images, Roman ISIM for generating calibrated and uncalibrated imaging data, STPSF for simulating high-fidelity point spread functions, and other tools like the Roman Wide Field Instrument ETC that uses the Pandea engine that you can run separately to help plan observations. We will have a webinar on this in just 2 weeks, Tuesday, November 18th. By the way, while I have everyone's attention, if you haven't signed up for our mailing list already, at our main webpage, you can find the instructions for signing up for the mailing list. That's where we will email all the information in advance for future webinars. As I mentioned, the Roman Research Nexus. This is a science ecosystem to provide a cloud-based collaborative is the key word. You can work with teams on shared data sets and shared Jupyter notebooks. This is a cloud-based collaborative computing space for the science community to explore, access, and analyze Roman's petabyte scale data, right? So I already mentioned this. You don't really want to download petabytes of data. Science software tools and tutorials are in the Nexus that will teach you and instruct you how to create your own simulations, to do the data reduction if necessary, and data analysis and visualization. And one more time, third time's a charm, all Roman data will be public with no proprietary period. So you come to the Nexus, when the data come down, you'll be able to access them. We'll have a webinar in the Nexus in January. We're expecting the launch between now and then. And we will have a webinar on the Nexus in January, right after AAS. We have a pipeline, calibration pipeline. This is called RomanCal to reduce and process the wide field instrument imaging data. And our expectation is that you shouldn't have to rerun this pipeline too often. We will be running the pipeline when necessary. You should be able to work with the data products, but nonetheless, the pipeline is available for you to look at and download. It's on GitHub. You can see what all the algorithms are. It's very transparent, and you can even learn how to run it yourself if you desire. Okay, so that all brings me now to these community-defined surveys. This is really the meat of today's webinar. And again, as I mentioned, many of you are new to the Roman community. So I really want to make sure that I introduce this slowly so you understand, where this is coming from. Community-defined surveys overall have been optimized for a broad range of science through a community process. This has now taken 2 years and has been built on the work of early science teams going back over a decade. The input that we received was from over 1,000 community members from more than 200 institutions around the world. And there are 2 types of community-defined surveys. One is what we're calling the core community surveys, the CCS. These are designed to address fundamental questions that have really defined the Roman mission science requirements, including things like dark energy, dark matter, and demographics of cold exoplanets. Even though those are the fundamental questions, I can't repeat this point enough. the surveys have been optimized to maximize the overall scientific return from the community. So there's a lot more science than just those topics that I listed there. The core community surveys have already been defined, and they allocate roughly 75% of science operations during the nominal 5-year mission. That said, as I've been saying, we really encourage users and observers to take advantage of these incredible data sets for their own science goals. There's also something we call general astrophysics surveys, and these may be community defined or PI led, where the PI led programs will be solicited through an open call for proposals and awarded via a competitive time allocation process. So far, we had one GAS program that was defined through an early definition process, community process, I should point out, and that is called the Galactic Plane Survey. So, where do you find information on all of these? Well, the original reports can be found, for the core community surveys, can be found on the archive. This is the ROTAC report, the Roman Observation Time Allocation Committee. This gives an overview of all the science trades that went into designing these surveys. The Galactic Plane Survey Early Definition Report is currently on the Goddard website. It should be on the archive in the coming days or weeks. And we have virtual webinars that were given specifically to describe these surveys to the community, and they can also be found on the Goddard webpage. But let's jump into a few more details here. We have these snazzy new graphics, courtesy of Space Telescope's Office of Public Outreach. And this is an overview map that shows you the 3 core community surveys, as well as the outline for the Galactic Plane Survey. So this just gives you an idea of where these surveys are on the sky. And it shows you the really the depth of all these different surveys, in the sense that they have different tiers, they have different volumes, they have different depths. And these are all going to be things that you need to think about when you're designing your proposals. So then the question becomes, which survey is right for you? And we're going to get into each of these in a little bit more detail. As a fun little exercise, before this webinar, when I sent out the instructions to the mailing list, I asked if everyone could fill out a poll on their priorities for their science with Roman. And this was really designed to give you to really have you start to wrap your head around all the different axes and trade-offs that Roman has available to it, specifically amongst the different core community surveys. And I tried to take your responses and break them down by category, based off of the responses that I received, which was admittedly only about 2 dozen. It was a small sample size, so I couldn't drill down too far, but I broke them up into 3 categories. One being cosmology, weak and strong lensing, the Milky Way, whether it's exoplanets or stellar variability, and also galaxy evolution in the local universe. And you can see those 3 different colors here. And then what we're going to do is we're going to overplot each of the surveys. It's sort of subjective. I assigned my own numbers to the surveys, but this is just illustrative. I'm hoping that this gets turned into a tool where individuals can really play around with it and figure out which survey is best for them. But here's what the High-Latitude Wide-Area Survey looks like. The High-Latitude Wide-Area Survey is going to be huge in volume. It's going to produce 600 million galaxy shape measurements over 12% of the sky, and 11 million spectroscopic galaxy redshifts over 6% of the sky, up to a redshift of 3. And it's going to be 1,000 times larger in terms of both imaging and spectroscopy compared to Hubble's largest deep surveys. And so the outline of this sort of nicely, lines up with some of the needs for galaxy evolution and cosmology, which is, some of the science drivers behind this survey, although there is this weird cadence outlier for the cosmology respondents that I need to look into a little bit more. The High-Latitude Time Domain Survey, this is big on cadence and depth. It's going to discover, it has a 5-day cadence that's over about 10 square degrees. That's going to uncover 20,000 Type 1a supernovae out to redshifts greater than 2.5 for cosmology, as well as 100,000 transient light curves overall. Also, the deep stacks, when you take into account all of the different epochs, cover an area of 100 times larger than Hubble's largest comparable survey. These are what I'm calling the cheat sheets. You can use these. We'll make them available for download. Today's sort of their premiere, so that you can do a quick look and see sort of what the parameters are and what science you can unlock with these parameters. Just to give you some ideas, we have some fun graphics that give you a sense of all the different science that you'll be able to do, and more. And the Galactic Bulge Time-Domain Survey. Oh, and I didn't really have a good comparison. Out of all the respondents that I received, I did not receive one person from the time domain community, or from the supernova community, I should say. So there's not a good comparison in that. I'm going to have to work on that myself. And then we have the Galactic Bulge Time-Domain Survey. This is 5 fields in the galactic plane, and 1 right in the galactic center. The expectation is that we will find 1,000 bound and free-floating cold exoplanets down to 0.1 Earth mass, with microlensing detections, and 100,000 new exoplanet detections, mainly with transits. We'll also have a lot of stellar variability and be able to do astroseismology on over 100,000 red giant stars. And so the name of the game here is really cadence, not necessarily field of view or depth. And so a lot of the people that filled out a lot of the Milky Way respondents, that really resonated with them. So you can compare the Galactic Bulge Time Domain Survey with the Milky Way respondents. Okay, so how do you learn more about each of these surveys? We have a number of tools. I already mentioned RDocs, but what I didn't say is that there are a suite of articles that are currently available that give full details on the implementation of the core community surveys. Those are already available, and coming soon will be more details on the implementation of the Galactic Plane Survey. If you want to start getting more into the details regarding your particular program, there are a few ways to do this. The first is the exposure time calculator tool, which is used to simulate astronomical observations and estimate signal-to-noise ratios for proposed WFI programs. This is heritage software that was adapted from JWST. If you're familiar with JWST, you should be able to jump right in. If you're not, there's a lot of extensive documentation online just waiting for you. This is built on the Pangaea engine and can be accessed through a web interface for setting up complex scenes and observations and providing detailed outputs like signal-to-noise ratios, exposure times, and feasibility assessments. We already have example workbooks for the 3 core community surveys and the Galactic Plane Survey that are available for you when you log in. You can already start playing around with those and looking at the different the different exposure parameters for different aspects of the survey. You can plug in your own sources and you can see if you achieve the necessary signal to noise on your sources for any given part of that survey. We'll definitely give you a lot more details about how to use the exposure time calculator. That's upcoming in a webinar in December. Another great tool is APT. This is the Astronomer Proposal Tool. And this is software for creating complex surveys, designing mosaics, and visualizing targets. You might be familiar with APT if you've used Hubble and Webb. This is crucial for planning observations, which with program specifications and APT directly influencing the automatic pipeline products for data processing. But even if you're not planning new observations, you can still use APT to visualize some of the all of the different core community surveys. Currently in APT are what we call demonstration programs. These are smaller representations of the community-defined programs so that you can get a sense about what their pointings, mosaics, and observing strategies are, and get a sense of how those could be optimized for your particular science. And they're all available through the file menu. And so we're going to be doing a lot more details on the Astronomer's Proposal tool at an upcoming webinar, again, in December. So mark that date. And finally, the live demo that we'll do at the end of today's webinar is a Roman footprint visualization tool that does complement APT. Note you can look at your core community surveys or any survey that you design inside of Aladdin within APT. But this tool allows you to look a little bit at more of a granular level where you can look at the number of exposures and the total integration time at any region of the sky. And so we'll do that demo at the end of today. I'll show you a live demo on how to do it. I sent around instructions on how to install it already, and we can answer some of those questions in real time. Okay, and then to wrap up, I just want to say that the Roman community is already going strong. And if you want to get involved or stay up to date, I encourage, there are several ways to do this. One, the lightest lift is just follow us on social media. Nancy Romansai is on Facebook, Twitter, Instagram, and Blue Sky. We also have what we're calling the Roman Science Collaboration. This is designed to amplify science returns from the Roman mission by bringing together collaborations that may not have normally formed. And so there is several different subgroups within the collaboration. This is led by Jessica Liu and David Weinberg. Each of the subgroups has its own chair, and each of the subgroups has dozens to even hundreds of people in it right now, starting to think about how to maximize the return from all of these surveys. There are not going to be a huge number of general astrophysics surveys accepted for new observations. And so it's really important for the community to come together now and try to prioritize what that science is going to be and how to maximize these surveys for the entire community. And finally, there are many other ways to get involved. Some are light lifts. You can just tune in. Some are more interactive, join webinars, learn how to use the tools, or you can actively contribute. We have active working groups, workshops, and committees, and there's plenty of opportunities to participate in all of these. And so if you go to that website in the bottom right, or you go to the QR code in the top right, you can learn of the different ways to get involved. So that's my 25 minutes. We're going to have plenty of time for questions. I saw a lot of different questions popping up. So why don't we move over to that right now? I don't know, Leslie, do you want to, how was the feedback from Slido? Did we get a lot of questions or should we do it a different way?
There haven't been too many questions in Slido. There was one question, can classrooms access the data? Will they need to submit proposals? That's the only one so far in Slido. And then there was one question about some proposals in the chat, so we can go back to that.
Okay. I'll answer both of those. And just as a reminder, if anyone wants to ask a question and you don't know how to use Slido, you can just write the question in the regular chat and we'll try to address that as well. Okay, so there were two questions. One was, will these slides be available? Yes, I'm going to post the slides and a recording of today's webinar online. So you'll be able to access all of these. The slides all have links that you'll be able to go to the corresponding tools and web pages. The second question was, will we be able to access the data from classrooms? And the answer is yes, anybody, anywhere will be able to access the data. You do need a Space Telescope account. It's called a MyST account, but those are free and open to anybody in the research community.
There was a question about if there's a Slack channel that folks can join.
Yes, we do have a Slack channel. The Slack channel is primarily open to people who join the collaboration. There's other ways you can get into the Slack channel if you're joining specific working groups or committees. And so if you follow the link or the QR code on this page, you'll be able to learn about the ways to sign up for either the working groups or the Roman Science collaboration. When you do, you will get an invitation to the Slack channel.
There's a new question. Are the proposal and simulation tools designed for download to run on the Nexus? There might be a typo there.
Yes, great question. So when the Nexus is launched, you will be able to run the simulation tools on the Nexus. One thing I should say about the Nexus is it will be a pre-installed Conda environment. You won't have to do any additional installation if you don't want to, and run almost all of the tools that we talked about today. However, all the tools are also designed to be standalone packages. They're all on GitHub, and you should be able to clone the repos and follow the instructions and documentation to run them yourself. And again, I encourage you, if you're interested in simulations, definitely come to this webinar and you'll be able to ask detailed questions.
All right, a couple more comment in the chat here. We've got, I learned about the Roman mission through the Exoplanet Watch program and the Carl Sagan workshop. Will Roman's exoplanet work build on or connect with missions like TESS or JWST in terms of follow-up or complementary science?
Well, I think the answer to that is that's up to you as a community member to make that happen, and I certainly hope it does. Synergy is definitely the name of the game when it comes to Roman. The way I like to think about Roman is going to be great at finding things, specifically needles in the haystack, and that other programs are going to be amazing at doing very detailed follow-up. That's not always the case. Don't quote me on that. It's not a blanket statement, but I certainly hope that there's going to be a lot of synergies. The details about official synergies, specifically with telescopes like Rubin or the Hyper Supreme camera down at Subaru, are still TBD. Except I would expect that we're going to hear more about official synergies in the future. But in general, I think that the number of synergies with Roman are infinite, and that those are really great ideas to write into a proposal.
Great. We had a question. Any news about the targets for the first images?
I gotta be political. It's the old saying, if I told you, then, you can finish that sentence. No, we're not allowed to release any of that information. In fact, I'm not even on the committee and I don't even know myself. But you might recall that earlier this year, there was an open call for ideas. Those ideas have all been processed by a working group who was trying to figure out what those first images will look like. And I expect that there will be an announcement in the future, or maybe at the time of launch, but that's going to probably be a secret until then.
All right, we got a question on the Roman ETC. Is it possible to upload a custom data cube with different wavelengths, spatial and spectral resolutions, and have the tool degrade it to match the Roman GRISM characteristics?
Oh, I don't
What
know about a cube. If
when it
there's
actually
somebody
answered that in the
from
chat.
RTB here who wants to take that question.
Yeah, I think it actually got answered there in the chat.
Oh, okay. Excellent. What was the answer? Can you read it out to everyone? They're
It
not paying
was
attention.
from Adric. Unfortunately, no, the ETC does not currently support uploading custom data cubes either uh, as the standalone Pandaea engine or as the web app.
Okay.
All right, I think we're caught up. There was one more question just asking to clarify how the data will be available to the public. Someone said, not sure I understand everything. Is it correct that to access the data, we need to enter something called a classroom? If you want to just clarify.
Oh, I'm sorry. Maybe I misunderstood that question myself. You do not have to be in a classroom. I don't know if the reference was to a software called a classroom. If I was thinking of a physical classroom. So if I misinterpreted that question, I'm sorry. You do not need anything except a computer to access the data. And a Space Telescope account on MyST. And in fact, maybe I'll add that link to this presentation so that when everyone goes later on, they can access MyST and create an account if you don't already have one. All you'll do is go to the Nexus, log in, and all the data will be at your fingertips.
Right, there's just a couple of questions about whether there's an approximate time frame for when the call for proposals will open and close.
I'm hesitant to say I should have known that question was coming and gotten an official answer. All I can say is I think it's a little bit TBD right now with the government shutdown. And we will hopefully, the Roman Project Science Office will hopefully provide an update on that in the very near future. If there's anybody on this call that wants to
Ori?
give a more official answer to that, I'm happy to, just unmute yourself.
Yeah, Ori, are you able to hear me? I can jump
Yes.
in. Okay, great. Yeah, so in terms of the approximate timeline, we were planning for, basically the call opening up really soon, and then the deadline, if we are able to open the call, will be planned for early March. But right now, with the government shutdown status, we are actually having things a little bit on hold. So once the government reopens, then we would have more clarity on when the call would actually be released. Thank you.
All right, we had one more sort of logistical question. Do we need to register separately for upcoming seminars in this series?
Great question. There's no need for pre-registration. We're trying to keep the bar low. It would help me knowing who was coming, but we also don't want to make people pre-register. So the best thing that I can recommend everyone does is sign up for the mailing list, and you will get a reminder a couple days before each webinar. There's also a shared calendar. You can either download. I think the web page has a calendar entry that you can download, or you can go to the public calendar on the Roman forum. That's not something I mentioned today, but the Roman forum is where the Roman community comes together. The Roman Science Collaboration, the working groups, really everybody. And we have a public calendar. You can also import that calendar into your Google Calendar, and that will keep you up to date as well. But it will always be this link at the dates that we were advertising, except if there are changes, you should be able to stay up to date with that mailing list or come back and check the web page.
All right, I think we are caught up with questions.
All right. So with that said, I have one last demo. It should take about 10 minutes and we'll end right on time. I want to show you how to use the Roman footprint visualization tool. I'm also available until the end of the hour to answer questions if you've been trying to run it yourself and run into issues as well. And we have some experts online that can help troubleshoot if you run into that. So I'm going to stop sharing and switch screens to my Jupyter notebook. I should also point out this notebook will eventually be on the Nexus as well. Right now, this is just a pull request, a PR. inside of the Roman Notebooks GitHub repository, but all of those notebooks will eventually be on the Nexus. And so you won't have to do any cloning. You won't have to run it on your local machine if you don't want to. Okay, so let me switch over. And sorry about that. Okay. Hopefully everyone can see my screen. And I just want to show you our webpage in case I'm going to put the webpage in the WebEx chat, just in case you haven't gone there before and you're getting bored. You know, you can go and check this out.
I just posted that, yeah, in the chat. But we'll go ahead and update that with some of the links and info we discussed today as well.
Excellent, excellent. So this is our main landing page, just as a reminder. We're going to have a specific web page for each of the webinars with detailed instructions on how to prepare. We have a number of important links that you might want to use to get started. And you can also find the calendar up here. I had mentioned that, but it's worth showing. And there's a lot of other great activities besides just the webinar. So if you import that calendar, you can stay up to date with all the exciting things happening with Roman. So today we're just going to do, for our last demo, running the Roman footprint tool. These were the install instructions. I know it's lengthy. This is what worked for me. And this live demo works about 50% of the time. So I don't know the magic, so I'm just hoping it works for us this time. So here it is. This notebook helps you visualize what your program is from APT. As I already mentioned, you can visualize aspects of that program already in Aladdin. However, this allows you to look at a more granular level, right? You can look at the exposure time at any single position, and you can scan around the entire sky. The nice thing is you can do this with your own APT file, or you can use some of the predefined surveys that we've already generated simulation files for. So that includes all the core community surveys and the Galactic Plane survey. And you'll get all of those files when you clone this repository. The files themselves are generated from APT using a script. We don't show how to generate those files here, but there will be a notebook on the Nexus that illustrates that step. For now, you can just assume we went from a survey that was in APT and we developed a simulator file. The simulator file can be used here, and it can also be used in Roman iSim to generate your simulations. This is the entire survey file as it currently stands. It's still a bit preliminary, right? The surveys are defined, but they're not completely finalized yet. There's a lot of iterations that still need to happen as different variables change, as the call for proposals comes out and we receive general astrophysics program surveys. But this is a near final design for the different surveys. And we're going to look at the High-Latitude Wide-Area Survey today. And so the first step, just if you're not familiar with Jupyter Notebooks, now is a great time to start learning. There's a lot of documentation online that will teach you how to do this. I'm not going to teach you how to use Jupyter Notebooks today, but in future webinars, we can certainly talk about that a little bit more. Furthermore, when you get the Nexus, you won't even need to worry about that. It's all going to be pre-installed for you. But when you have Jupyter, you do want to just make sure you have all your programs installed. I've already installed these packages in my instructions, but this is just a double check. Then you import the programs, packages that you're going to want to use in the notebook. You set your matplotlib settings, and then you load up these simulation files. And so here is what the table looks like. You have a number of columns: RA deck, position angle, bandpass, your MA table number, duration, plan, path, segment, observation, visit, exposure. I say all those terms out loud. You don't need to know what they mean today, but these are all terms that are specific to your program inside of APT. And we have extensive documentation that defines what each of these columns actually means. But these are going to be words that you probably need to use, know what they mean if you are going to be using APT for Roman. But for now, you can just think that they define what your survey looks like on the sky. And we're going to look at just a portion of this survey in a single band. We're not going to worry about the whole survey, and I'll tell you why in just a second. And we're going to see if this visualization works. I'm keeping my fingers crossed. Okay, so here is the visualization of a portion of the survey. It's not the entire thing. But here is the declination, and here's the right ascension. You can see the map is for the exposure time. The exposure time, of course, translates into a sensitivity or a limiting magnitude that you can calculate independently in the exposure time calculator, depending on the type of object that you want to look at. The plot here is not in terms of sensitivity, but in terms of exposure time. And what's nice is, Matplot is now very interactive, and you can draw a box, and let's see if we can do this here. Zoom in to any single position on the sky. You can see longitude and latitude in the bottom. RA and DEC are the axes, and you can look at how your integration time changes at each individual pointing. The nice thing is when you load the entire survey, you can do this across the entire survey to really get a sense of what you're dealing with. And maybe you have a favorite galaxy in a certain part of the sky and you want to know what the depth is going to be at that location, right? So you can also import this map onto your own maps, and you can have them interact with each other. So let's say you want to do your own survey and you want to see how that survey is going to interact with one of the core community surveys. This is a great way to do it. If you want to load the whole entire survey up, that's a little bit more difficult. It's a huge file and it requires parallel processing to actually make that possible. That takes about 15 or 20 minutes to run at the current time. I can start that, but there's a good chance it will end by the time this demo ends. And this is also sometimes where I get a crash, but we'll do it nonetheless. And if you want to stay on till the end at 2 o'clock, you can, 2 o'clock Eastern, or I can just post the recording later. But that really ends my demo, and I'm happy to answer any questions. If you've been trying to run this yourself and you've run into issues or you have questions about individual cells, we can go through that now. I'll give it about 30 more seconds for a question. And if there are no more questions, and you can ask about the notebook or you can ask about something else that you heard earlier that is still not clear. So somebody asked, is the correct workflow to first use the ETC to check exposure times, then set up the APT, and finally use this to visualize the footprint? That is a great question. I think these tools are all designed to complement each other. And so I think what you're going to find as you start thinking about what your proposal is going to look like or what sort of observations you need to do your science, there is no correct order, but you're going to have different needs. Are you going to have to look at individual points on the sky and see what the exposure time is? Is it more important to understand what the sensitivity is for your specific object? Will you need to see mosaic patterns and the number of passes that occur at a given cadence? where cadence might be very important. You get that from the APT file. So I think it really depends on what your science needs are going to be, and understanding that each of these tools brings something different to the table. And you're going to have to think about how you need to put those tools together to make the case to the TAC that your science is going to be possible. But great question. When you get an answer to that, come back and tell us how you do it. So this said, is there a simple way to use this tool without relying on the APT? That's another great question. This tool is already designed not to be used with the APT. If you clone this repo, you can play around with the survey that you read in, which is up here, and the different slices or the different filters that or segments that you're going to want to look at. You don't need APT to do that. If you are designing your own survey, you will need to design your own survey in APT and convert that APT file into a simulator file that you can then load into this notebook. We got another question. Is the expectation that GAS proposals are to be done with the RSCs, or is that not an expectation and GAS proposals can be done by any team? Yes, I want to be entirely clear. GAS proposals can be done by any team. There's no requirement that this goes through the Roman Science Collaboration. The Roman Science Collaboration is really just a spot where we can bring different ideas together that may optimize the surveys and make them stand out because there's not going to be a large number of GAS proposals accepted. More of that discussion is going to be in the call for proposals. I don't want to overstate anything at this point in time, but the Roman Science Collaboration could be a great place to bring multiple ideas together to really maximize the science for those surveys, if that makes sense. All right, another question. It's non-ETC. The High-Latitude Wide-Area Survey wide tier overlaps with the ecliptic plane. In addition to the ROTC, is there more info, supernova, signal to noise ratio with respect to distance from the ecliptic plane on the impact of zodiacal light on imaging spectroscopy? That is a very good question. I don't know the answer to that. We have working groups that are thinking about these things. I don't know if there's a representative from any of these working groups that is online right now that might be able to take the zodiacal light question. I will make a note of that.
Corey?
Yeah, sorry, did somebody speak up?
Corey, it's Rachel. Oops, my camera's
Yes,
over here. There is a background estimation tool that we're expecting to release very soon. I believe it might be findable, but the documentation will go up very soon. And so that background tool will let you see the different terms going into the background. So there's different background considerations that go in, and you can do a position on the sky and see what all those terms are. The ETC also has a workflow where you can get a feel for the total background. But
we lost Rachel at the end. I don't know if that's just me or somebody else, but there will be a tool is the short answer, and stay in the loop, and we will advertise that tool when it comes out. All right, so we have 2 minutes. So here, look, it did load. Now let's see if we can actually zoom. This is the entire High Latitude Wide Area Survey, so you can really explore the different tiers. And let's see here. Yay! My live demo worked. And so that allows you to do it. Sometimes my notebook gets hung up. I don't think that's a notebook problem. That's just my personal notebook environment. But you can play around and explore the different aspects of the entire survey here. All right, so with that said, I think this is a great place to end things. I'm very happy to see everyone. I hope to see you at future webinars. If you have any feedback, you can definitely email the address that you got the reminder from, which is Ready Set Roman Training Series, RSRTS at stsci.edu, and we will take them to heart. But again, we hope to see you in the near future and definitely hope to see your proposals. So thank you to everybody. And you can access the slides at the main website that we put in the link. I will put them up. Probably today in one of probably right here. All right, so you'll be able to access it right here. All right, thank you, everyone. Bye-bye.